Good morning, everybody. At the outset, I must congratulate the organizer for organizing such a nice conference, especially in Kolkata. The conference name is Analytic Global Conference, but from the previous speaker, what I have learned, this focus is on AI/ML. But at first, I must admit that I am not a person from AI/ML fraternity. So my research includes the network security, and of course the usage of AI/ML little bit in some of the works. But see, there's a debate that AI/ML nowadays this is buzzword that AI/ML everywhere. But I am not a person to comment on that whether AI/ML is the last word or not. AI/ML, the way I see, it's a tools and techniques. Everyone can use it appropriately if it is at all workable in a particular application. But I will share only the application where we have used it. But before going to the how the learning method we have used, until and unless I say something about the application domain, the application specific requirement, then it will be useless for the audience to follow the second part, that is how we have used it. And the specific what we have done, in short, is called SPRITE, the privacy preserving and verifiable collaborative learning. But the last part, that we have used blockchain for different purpose or for improvising our work, that part I will skip. Only I will restrict my talk within the premises of this, how we have used it. Embedded system with physical environment, and this is an example of course, cyber physical system. So most of you are familiar with IoT, and this is a specific application domain of IoT in industrial domain. Integration of certain IoT technologies with information technology with minimal human intervention. And another buzzword nowadays, people say that Industry 4.0. Again, I am telling that I am also not the expert of Industry 4.0. Only I have picked up an application where people say that Industry 4.0, it is called Industry 4.0 is complete automation and special emphasis on manufacturing industries. This word is very important in this context. This is real-time intelligence. You know that if you collect big voluminous data and if you analyze it with some technique in a city office, in a AC room, then it is something called offline. It's not real-time. But the challenge lies here where real-time, where the actual work is taking place, and along with that intelligence you are applying. It is easier to apply computationally intensive techniques later after collecting the data and come to a decision. But real-time intelligence is really a challenge. This is our architecture where we have used broadly, there are 4 layers: perception, network, processing and application. Now in our industrial IoT, the perception layer, the lower layer, by means of which the data are being collected from the ground, those symbolizes the specific need of industry floor, like automated guided vehicle or robots, sensor, intelligent eye. These are the some of the devices typically used in industrial floor at the perception layer, if you call. Next layer is, as you know, that called network layer, and then it's being processed in the application layer. Application layer means when the data is collected to a server, maybe in a cloud server, then it may give some services to the user. The user may be end user, or user may be the manufacturer themselves or the company people themselves, for getting some feedback, for getting some analyzed, summarized data, observation, etc. Now, drawbacks of this architecture is creates a central point of failure. If you use the server, cloud server, if the server is down, then is a central point of failure, just like any other centralized system. Process time-sensitive data in cloud, and users have limited or no control over their data. Data can be tampered or deleted because cloud may be malicious, cloud may be attacked, so significantly limits the growth of IoT. In this context, the requirement is locally processing tasks in a timely manner. Solution is introducing a potential middleware. Locally processing tasks in a timely manner means if we completely rely on cloud and the data, every bits of data in a raw form or some filtered form, it goes directly to the cloud. Even we have to rely on cloud. So to reduce the burden of cloud as well as to reduce trust from the cloud, the solution is why not we introduce a middleware. So save battery life of low-end devices. Net energy consumption should be positive. Means to offload the data to an edge device might be that basically we are spending more energy compared to when there was no edge. That is not acceptable. Means if you extract too much knowledge and filtering too much, then might be it will be difficult to get back the original data. Filtering of too much raw data may lead to problem of knowledge extraction in future. So if you filter out most of the important things, then it will be difficult to extract information out of it. So in this context, another issue is security and privacy. Efficient handling of sensitive sensory data is a challenge. For example, especially in developed country, that if in a health monitoring application, that patient may not divulge their own data. So challenges of edge computing means these are the challenges, technological challenges. So we have to, whenever we will develop, we will propose, we will design and develop something, so we have to keep in mind all those things. Now what is fog computing? Before going to the definition and all, this is the diagram which is self-explanatory. You know that the first layer mobile devices along with the edge, and the second is fog, means a little bit higher with higher computational capability, and then goes to the cloud. So in this, by introducing a fog layer, we may reduce the trust on cloud. So if the application is very sensitive, the data sensitive, so the security is a concern. So every data, every piece of data, if you send to the cloud, then privacy will be challenged, and might be that security in some applications will be exposed. Vulnerability will be there. Our adversary model is IoT devices and fog nodes are honest but curious, cloud is untrustworthy. And assumption is each iteration finishes on a fixed interval, all devices in the correct model gets updated in each iteration. IoT device fog nodes never deny to communicate with each other. Now, this is the working principle, that local training, different devices are there, performs local training and generate local gradients. I am not going to the detailed mathematics, but some kind of gradient algorithm we have used, and now they performs local training and generates local gradient, generates secret share on gradient on distribute them. Means many devices are connected with the fog. Now these devices, what they do, that they generate the gradient and they distribute among other devices the share of it, and one part it keeps. In this manner, all the devices generate their gradient and share among the devices. Prevent poisoning, to prevent poisoning attack, this is also not possible. Detect malicious parties in case of corrupt behavior. And that is why we have at the end, we have used blockchain. That part I am not using it. It is part of another word. Now this conclusion, I have come to the conclusion, to the best of our knowledge, such a fog-based network design still remain unexplored, and Sprite is resilient to device dropout. This is also an important observation or conclusion. And future plans are developing a prototype in Ethereum to establish the efficacy using blockchain, of course, and extending the scheme by considering the device may be malicious. So with this, any questions, if time permits?